Welcome to Zimcan IT. In today's video, we're going to be implementing virtual networking with Terraform. Now, this is going to be virtual networking within the Azure cloud, and we're going through a pre-built lab by Microsoft for the AZ-104 exam, of which I'm preparing for. And so, having already done the configuration of this lab within the portal, I decided to codify it using an infrastructure as code tool called Terraform. And so what we're essentially setting up, if I go to this here image, is a resource group. And then within this resource group, we're going to have a virtual network. A virtual network is simply a self-defined network within the cloud, Azure cloud in this instance. And we split this virtual network up into two subnets, subnet 0 and subnet 1. Class C IP addressing. We're using IPv4 addressing as well. And within each subnet, we will have two virtual machines. In fact, one virtual machine within each subnet, a total of two. And associated to the network interface card of each virtual machine will be a public IP address. And we're then going to assign a network security group on the actual network interface cards of these here virtual machines, which will lock their access through the RDP protocol via port 3389, so 3389. We are also going to implement private and public DNS zones. So for internal communications, we'll be using a private sort of domain name, which will be contoso.org. And as for the DNS zone that's implemented publicly, I should say, you can essentially create one of your choosing. So let's just talk through what the lab requires of you to do, and then we'll look at the Terraform configuration before we actually deploy resources through to the cloud. Right? It's important to note as well that you will have access to the GitHub repository of this project, so you can reference that as well if you want to sort of go along with the video. So obviously task 1, you sign into the Azure cloud. Let's zoom in a bit. There you go. You sign into the Azure cloud. You head over to the virtual network section and you create your virtual network within this here resource group, RG1, obviously VNet1. The region, that's going to be the region within which your resources are going to be deployed in. So choose that carefully, as not all regions have the full suite of Azure resources, cloud resources available to them. You can create your subnets. Obviously there's the IP addressing for that. You deploy your virtual machines within the virtual network. You're going to configure your private and public IP addresses as previously mentioned. Configure your network security group. And so this here network security group permits inbound traffic from any source. There you go. However, I locked it down to be just port 3389, which is the standard port for the RDP protocol, remote desktop protocol. The virtual machines, if we head over back to the image, in fact, the virtual machines are going to be Windows virtual machines. And so we'll look at the spec of the machines themselves, pre-deployment. And what else do we do? We then configure internal name resolution. So that's the 5th task we're going to sort of look over within the Terraform config. Create a private virtual network link, and we'll test the internal name resolution by running some commands. All right, within the PowerShell admin console of a virtual machine, and we'll then implement public DNS name resolution, so external name resolution. Now, within the 6th and final task, prior to terminating resources deployed within this lab, they ask if you to go to the GoDaddy website and search for an available domain name that you'll then use within your configuration. However, this link wasn't working for me, so you can actually use Google's domain name search utility. It's just a quick sort of Google search there. Now, obviously, once you locate a domain that's available to use and create within your DNS zone, you will be required to create some A records for your virtual machines. So that's this sort of task here. that's about it. You just test, once again, the external name resolution of your DNS record sets, which should yield the public IP address of the virtual machines that are deployed. Okay, so that's that. We're going to, I did summarize the lab, and the Terraform code itself has been set within this here repository. So it just breaks down what you need to know, what you need to have as a prerequisite. So, you know, some elementary sort of beginner knowledge of Terraform would help. If you've never touched the language itself before, you'll need to install Terraform, as well as the Azure CLI, because the workflow for this here Terraform configuration is going to be a CLI driven workflow, meaning you'll be initiating runs of your infrastructure deployment from within the command line interface locally on your desktop PC or laptop. There isn't any sort of CI/CD involved, as we're not, you know, using Azure DevOps to build out the infrastructure and then release it. So we don't have a build and release pipeline, things of that nature. It's just a simple standard CLI driven workflow with your Terraform state stored locally. You do need to have a terraform.tf vars file. Okay, so if we head over to the infra subfolder, we actually have a variables Terraform config, which references values that are declared within terraform.tf vars. So your tenant ID, which is simply representative of the organization of your Azure Cloud subscription, Azure Cloud, I should say. Then you've got your subscription ID. The subscription ID references the isolated environment or unit of billing within which your resources will be deployed in. That's declared also within terraform.tf vars, in addition to your virtual machine password, so VM password there, which will be used to authenticate to the virtual machines locally and not within the Azure cloud via the RDP protocol. We have a locals block, and within this here locals block we have a resource prefix. So for the purposes of naming our resources, they will all begin with AZ104-04, so reference to the exam I'm preparing for, the Azure Administrator exam, in addition to the lab number. So there you go. We've got our subnet IPs and some tags which are applied to the resource group of this here configuration. So let's reference the image once again, and then we'll look at the configuration prior to deploying it. So resource group, virtual network. Within the virtual network, 2 subnets. Each subnet has a virtual machine. The network interface card of each virtual machine has a public IP associated with it, in addition to a network security group that locks the RDP protocol to just port 3389. We implement internal as well as external name resolution to our virtual machines, and that's that. Very simple, short and sweet. So let's look at the configuration. I'll put this here to the right hand side and the image to the left, so we have a point of reference. If I head over to terraform.tf vars, obviously you can't see my subscription ID, tenant ID and the like. If I just zoom in a bit, it's probably better. What you can see is that we declare a subscription ID, tenant ID and virtual machine password as previously mentioned. And if we head over to the variables config, we then declare the actual name of the variable that's going to be referenced within the main. If we head over to within the main.tf file, right? So starting out, we have our Terraform configuration block, which states the provider we're using. So it's the Azure RM, which is the Azure Resource Manager provider. We're using the version 3.00. The most up-to-date version is 3.31. But for this here version, or for this here deployment, 3.00 is perfect. Now, within the Azure Resource Manager provider block itself, we state that we are going to use the following features. So these will control how the deployment of resources will be managed. We're preventing the deletion of the resource group if that resource group still contains resources. So we're ensuring that all items are deleted once the lab has been run, which is a good feature to include when you want to ensure that everything is purged prior to deleting your resource group. We're also then ensuring that the OS disk associated with each virtual machine is deleted as well, and that the virtual machines request a graceful shutdown when the Terraform destroy command is run. Obviously we state our subscription ID, because if you have multiple subscriptions, you want to specify within which subscription in Azure you'll deploy your resources, and obviously the tenant ID, which is representative of the organization. We have our resource group, as you can see on the left hand side of the image, RG1, and we're using our local prefix for naming conventions. I've deployed my resources within the West Europe region. It's just convenient for me. So let's head over to the network section. It's a bit larger, nothing too fancy. Again, we've got a virtual network. We state the address space, or the IPv4 address for that virtual network. We then create a subnet. Now we're using the count feature. You can either use the for each, which is recommended over count. However, in this instance, we're using the count method, built-in sort of method within Terraform, to specify that we're going to deploy 2 subnets. Now this is based on the length of a variable within the locals block called subnet IPs. So heading over back to variables and back to subnet IPs, we can see we have 2 declared items within this list that are the IP addresses for our subnets. So 10.40.1.0 over here and over there, right? So going back to network.tf, we declare our subnets, we create 2 public IPs, okay? These are statically allocated, okay, and of the standard SKU, and we create our network interfaces, and we associate the public IP address that we created at this point here to our network interface. So that's essentially the sort of virtual network, virtual machines, or network interface and public IP side of things. Heading over to security, very simple. Bear in mind the network security rule is associated to the network security group. So you create your network security group, and then you create your network security rules within that group. So you've got your group here, which is essentially being deployed within the same location as our resource group. Okay. You state the resource group name, I should say, of your resource group, of course, makes sense. Now, the security rule has a priority of 300. Within Azure, the lower the value for the priority, I believe it starts at 100. It essentially means that that rule carries greater weighting, or takes precedence over rules with higher priority values, okay? Again, the destination port range, that's a port range within which we'll be communicating with our virtual machines via RDP, so it's 3389. And we associate the network security rule once more with our resource group and the network security group that we've declared. And the combination of the network security group being associated to our subnets is via this here, Azure RM subnet, network security group association resource. So there you go. We've not yet gone through the virtual machine side of things. So again, we're using the count method to deploy 2 virtual machines. We're using our locals naming convention, deploying the virtual machines within the same location as our resource group, and then stating the size. So this is a B series virtual machine. They're typically used for development, testing, and not production standard virtual machines. This here virtual machine itself has a capacity of 4 virtual CPUs and 16 gigabytes of memory. So you're probably you're most likely used to gigabytes. However, gigabytes is actually what we use to measure memory there. So we associate our network interface cards to the virtual machine with this here block network interface IDs, and obviously we state the storage account type, and then the image of which will be running on the virtual machine. So we're using a Windows server with 2019 data center here. So it's a Windows server 2019 data center using the latest version, where it states admin password. In a production environment, you will not declare your passwords in hard code. Okay, do not do this. This is essentially just a demonstration, a lab, and should not be done in a production sort of environment. you would most likely have something such as a key vault within Azure, which is a container for secrets and certificates and things of that nature. So your secret would be the virtual machine password stored within key vault, and then you'd reference it within your deployment, whether it be via service principal or system or user assigned managed identity. But that's beyond the scope of this video. Now I'm going to deploy this here infrastructure. The process that we're going to go through to deploy the infrastructure is very simple. We're going to authenticate to Azure via the sort of AZ login command. If we go here to the repo, you'll see that, yeah, so we're going to authenticate to Azure via the AZ login command, and then we're going to run these commands here, Terraform init to initialize our backend. Okay, we're going to validate our infrastructure from a syntactical perspective, and then we're going to create a plan. We're going to review the plan to see what resources are going to be deployed, and then we're going to apply the plan, and then head over to the Azure portal to view what we have created, and then test our internal and external name resolution as per this here diagram. So I'm going to head over to Azure, grab my subscription ID, tenant ID, and then set a password for my virtual machine. Right, so I've set my variables within the terraform.tf vars file, and I've ran the AZ login command. Now, if you don't know what that means, it's essentially a way of authenticating to Azure via the CLI locally. So you will have reference to this guide within the README of this project. So I'll state it within the useful link section. And this is essentially what I'm referring to. So it's how you can authenticate to the Azure cloud via your local sort of CLI, which will then allow you to run the Terraform sort of commands, the initialize command, plan, and the like. So I've already done that. Now what I'm going to do is head over to the next step. So I'm going to run Terraform init to initialize. Okay, we're in an empty directory. What does that mean? It means we're in a directory that does not contain any configuration files. Right, so we're being told to create some Terraform configuration files, but what I do know is that we're actually supposed to be working within the infra subfolder, just referencing the infrastructure we're deploying. So make sure you're working within the infra subfolder prior to deploying or running the command Terraform init, as it states here. So let's do that. We're initializing the backend. Seems to be good to go. Successfully initialized. We're going to validate our config. Obviously there aren't really any issues. I've already sort of built this, and we're going to run a plan. So let's just extend this a bit. Shouldn't take too long. All Terraform is essentially doing is walking through the configuration files we have set. So main.tf, network.tf, security.tf, and generates a plan of what is to be created. So we're going to be adding 19 resources. And as you can see, we're going to be having an admin password of a sensitive value, an admin username, and it just states what the values will be for the resources we'll be deploying. So we've obviously know that our virtual network name is going to be AZ104-VNet1, but we don't know what the ID will be for our subnet, for example. So that states known after apply. I'm pretty satisfied with this here plan. It's representative of this here architecture we'll be deploying. So I'm going to head over to the next command, which auto approves this plan, and paste that into the terminal. So Terraform will start to issue out some commands stating, started creating X resource, and it will state how long the resources will be taken to complete. So as we can see, we started off by creating our resource group, and that took 1 second, creation complete after 1 second. So it shouldn't take longer than 5 minutes. I think what takes the most amount of time is a generation of our public IPs. The element that I will need to go through again will be within DNS.tf. It's just the process I went through to determine what my public domain name would be for the DNS zone that's public. So we'll go through that process at the end. It's very simple, but we'll just let Terraform run, and it won't take much longer, as the deployment itself doesn't contain much. It's now at the point of creating a private DNS zone virtual network link. So that would be within our private DNS zone here and the virtual network. So start creating a link between the two so that the virtual machines themselves will then have that DNS sort of suffix contoso.org associated with them. And yeah, so I'll just skip this part of the video and then we'll head over to the next step, which in the original lab source is to actually test your internal name resolution. So that would be task 5. Yeah. So task 5, you want to head over to the Azure cloud. You want to click on the connect button once you've located your virtual machine, and then log into that virtual machine via the RDP protocol. So let's head over to that now. Right, so the deployment was complete. All 19 resources, as had been stated in the plan document, have been deployed. And if we head over to task 5, as per the original lab source, it states you want to go to your virtual machine, log into it via the RDP protocol, and then launch a Windows PowerShell admin console. And then within that console, you're going to run these here commands: nslookup az104, so which is az104 referencing the name of the virtual machine. So just head over back to this image, az10404 VM0, so that's the first virtual machine. And your output should contain the private IP address of your virtual machines. Okay, so that's task 5. Heading over back to Azure now. Just zoom in a little bit. At the resource groups section, if I just hit refresh, we'll see that the resource group has been created. If we open up that resource group, we can see that we have all of these here resources deployed. So you've got your network interface cards, your network security group. Even just taking a look at that network security group, we can see what rules have been set. So we have an explicit allow from any source on port 3389, right? So that's the rule that's been set. Heading over back to the resource group, we're actually going to head over to our virtual machine, connect to our virtual machine via RDP, and to do so you'll need to download the RDP file. So we'll just throw that. If we get rid of this one, get rid of that one, and then save this. Yeah. Once downloaded, just connect. Now obviously the name here has been set as my original name, so we're actually going to use a different account, and then we'll state the admin name for the virtual machine that has been set on the virtual machine.tf file. So there you go. We're actually going to use this here admin. So admin username, and then the password that you'd set within your terraform.tf vars file. Just going to hit OK. Yes. And it would then launch our session. So hopefully you can see this. We're just logging into our virtual machine here. At the top you see there's the public IP of that VM. We want to open PowerShell, so you could just hit Windows R and type in PowerShell, and obviously it states that this task will be created with administrative privileges, which is exactly what we want. So PowerShell, let that load, and you can tell in the top left it says administrator Windows PowerShell. Perfect. So we're just going to hit the command ns lookup. Okay, so name server lookup, and then it's az104. I feel like I've hit a typo here. Yeah, because it's stating non-existent domain, but I do know that the domain contoso.org does exist. So it's just the way I've referenced this here command. There you go. So we have outputted this here value, which will be the private IP address of our virtual machine 10.40.0.4. And if we just run the same command but for VM1, which is our second virtual machine, you can also see its private IP. So the internal name resolution has been set or created successfully. The next task is to just close down your remote session. And if we head over back to this here page, we've implemented our private DNS zone with this here suffix contoso.org. The task that we have to complete now is to essentially open a web browser and search for a publicly available domain name. I've already done so. So within DNS.tf, again, you'll reference that it does contain zimcanit.training.com. Nobody's ever used that domain name, so it was publicly available for use for this lab. So with that being said, you just want to head over to this here link, godaddy.com, and then search for an available DNS, or domain name I should say. Then just change this here variable for the name value of your Azure DNS zone, okay? Simples. Now what they want you to do here is head over to Cloud Shell and then run the command nslookup, the name of your virtual machine, the domain name that you have chosen, so that will be the variable that you set here for your Azure RM DNS zone within the dns.tf configuration file, and followed by the name of your name server. So if you don't know what your name server's name is, don't sweat it, because just head over to your resource group within the Azure cloud I'm in. Go to the resource group itself, and it's your first name server that you want to grab. Okay, so that's the value you want to grab. So just launch Cloud Shell, which is an interactive shell for either running PowerShell or Bash. Okay, within your Azure Cloud Platform, and then run those commands once again. So go back to the lab. Where is it? Yeah, just grab this. There you go. Obviously, this is my domain name here. Okay. Just enter. Boom. There is the public IP address of our virtual machine. Now, how do I know that? If I go to virtual machines, and this is for the command run on VM1, so our first virtual machine. Just head over to VM1 again and go to, I don't even think yet, you don't even need to go to networking. You'll see that the public IP address is 137.117.247.146. Exactly what we have here. So within this lab, you'll have successfully implemented public or external name resolution as well as internal name resolution within the Azure cloud using Terraform. Now, your last step is to destroy your configuration of these here resources. Obviously, you can have a play around, but within the sort of cloud here, and just within here, Azure Cloud, I should say, and just take a look at what you've deployed and name servers that have been set, and things of that nature, and just try and get a grasp of what's being deployed and how it's all interlinked together and how it's working. The benefits of resource groups, there's a plethora of them, in fact. But if you want to have a deeper understanding of why we deploy resources within resource groups, or why a virtual network, the IP address that you choose for your virtual network has to be set in a specific manner, there will be sort of additional links within the GitHub repo that you'll have access to in the description of this video. So, final command, if we head over back to resource groups, which we're at, I'm going to close Azure Shell, Cloud Shell I should say, and we're just going to run Terraform. In fact, yeah, that's fine. We're going to run Terraform destroy. Auto approve. So we're destroying the infrastructure that's being deployed. So this will stop our virtual machines via the graceful shutdown feature we had set in the main.tf block. here. So it's going to be a graceful shutdown of virtual machines. We're going to delete the OS disk associated with these virtual machines, as well as ensure that the resource group is completely empty prior to deletion. It's also important to note that certain documents, or certain folders I should say, and files have not been uploaded to the Git repository because of the git ignore file, right? So within the git ignore file, you can just reference the comments which state what Git will not track and then commit to the repo. So that includes our crash logs, the TFRs file, which contains sensitive data, being our virtual machine passwords, tenant and subscription ID, and the TF plan document that we deployed, and any log files. Okay, so it's pretty simple. Just head over back to command line. When you run the Terraform destroy command with the auto approve feature, it will generate a plan document of all the resources that will be destroyed. And as you can see, if we scroll all the way up to the top, we're going to be destroying our DNS A records set for the DNS record that we use for our public or external name resolution. Okay, so the domain name there will be purged. We're going to purge the network interface cards and the like, and all that, right? So there's a lot to go, and as you can see, it's destroying. But aside from that, that is essentially this here lab in a nutshell. So heading over back to this here document, we deployed a resource group. Within it, there was a virtual network, 2 subnets, a virtual machine in each subnet, network interface card associated to these virtual machines, in addition to a public IP address, separate, of course, 2 public IP addresses associated to each virtual machine's NIC, and a network security group that locked access to each VM via the port TCP port 3389 for RDP. So if you did gain any value from this video, notably on how you can use Terraform to deploy resources within the Azure cloud, then feel free to leave a comment in the description below. If you have any questions, also drop them in the comments field below. There will be useful links within the description box of this here video, and enjoy the rest of your day. Peace.